Okay, so this worksheet 12C is the third video of the even numbers. Okay, we're still concluding the sum here. So we're saying since A1 is equal to ACB, which is equal to 64 degrees. Okay, therefore AOCB is a cyclic quad. Why is it the cyclic quad? Because there's the converse of angles in the same sequence. You could have written that down. Or we say equal angles subtended by same chord or same line. Okay, the same line or same chord. Okay, so it has to be a cyclic quad. A circle can then go through those points there. Okay, so now we're going to look at the last one, which is number 8. I'm just going to paste it. Okay, so now we're looking at number 8. Okay, so now we're looking at number 8. In number 8, we are told that EOC is the diameter. If this is the diameter, that is 90 and this is 90 here. Okay? Angle in semicircle. Then we are told that AB is equal to BC. So 90, 90, common. Looks like we're going to apply congruency here. Okay? Might be wrong. Angle A is 22. Determine the size of B2. Right, so we already see that's 90, so that's going to be 90. So B1, well, remember whatever is not on the diagram, I must state it. So B1 is 90, angle in semicircle. Okay. Then B2 is equal to 90y. Angles on a straight line. Okay. So that was fairly simple. Number 2. Number 2, they want you to work out E2. E2, sum of triangles. Okay. Triangle ABC. So E2 is going to be 180 minus 90 minus 22, which is 90 minus 22 is 68. 68. The reason here is sum of triangles, and it's triangle ABE. Okay? There's 68. Alright. Next question. C2. So C2 is this angle here. Okay, so I'm going to prove congruency there. Once I prove congruency, I can conclude it's 22. Alright? So it's an in triangle ABE and triangle CBE. Alright? We know that BE is a common side. Okay. B1 is equal to B2, which is equal to 90. Proven. Okay. AB is equal to BC. Given. Whoops. Given. Okay, it was given equal there. So we can conclude therefore triangle ABE is congruent to triangle CBE. Is the order right? ABE, CBE. Yes, is correct. Now, and the reason for congruency there is side angle side. Even though I used the hypotenuse, the right angle. Okay, we didn't use the hypotenuse, which is the side opposite the right angle. So it must be side angle side. Now I can say if these triangles are congruent, therefore angle A of that triangle is equal to angle C of that triangle. Angle B is equal to angle B, we know that already. So, therefore, angle A is equal to angle C2, which is equal to 22 degrees. Why? Because triangle ABE is congruent to triangle CBE. Okay. Let's look at number 4. Number 4 wants you to, so I'm just going to put 22 in here. Number 4 is looking for C1, which is this angle here. Okay. So angle at center is twice angle circumference. Okay, we don't have that angle. C1 and angle D is the same. Angle D1, because where it's angles opposite equal sides. C1. This is 90. Okay, so since that is 90, I can go with sum of triangles here. With triangle EDC. Can you see that? Because I know E1. E1 is going to be 68 degrees, no? Because the two triangles are congruent. So I can calculate the angle CEB, because the angles on a straight line. Okay? And then sum of triangles. There might have been an easier way, but I can't see it now. I'll probably get it afterwards if there is an easier way. But no train smash. I'm going to go with calculating E1 first. As we said, E1 is the same size as angle E2, which is 68 degrees. Why is that the case? Because triangle ABE is congruent to triangle CBE. Okay? So we're going to now say that CED is 180 minus 2 times 68. And we see that these angles on a straight line. Okay? So 180 minus 2 times 68. It's going to give you 44 degrees. Okay? Alright, so we got 44 degrees here. Just fill in our findings. If I had made any mistake, you can just refer to that number there. Or if there's an easier way of doing things, if I haven't mentioned it, again you can call me on that numbers. Otherwise, these videos are free. So that is 68. This is 44. Okay. So we see this is 90. Since it's not on the diagram, I must state it. So EBC is 90. Angles in semicircle. Okay, now we said we're going to go with sum of triangles. So angle C1 is equal to 180 minus 90 minus 44. So we're going to give you an angle of 46. 46. And the reason is sum of triangles, and it's triangle ECD. Okay, so this diagram is becoming very messy. So that is now 46 degrees. Okay. Alright, last question. They want you to work out EDC. 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 But we worked with EDC already. So EDC is equal to 90y, because angled in semicircle. Okay. So EDC, yeah, 90 degrees angled in semicircle. So definitely there was a way of working this one out without going this mile, this. Oh yeah, if I had said this is 90, I could have said angles in a triangle. Sum of angles in a triangle. That would have been so much quicker than what I did in number 4. Okay, so there already is an easier method for number 4. I just had to say that ADC is 90 degrees y, angles in a semicircle, and then 22 plus 90 plus C1 plus 22 is 180. sum of triangles in triangle ADC, then you would also should have gotten 46 there. Okay, yeah, you'd have gotten the same thing. Okay, so in geometry it's just like that there's many ways of approaching the sum, and you'll get the full marks as long as you're applying the rules according to the statement correctly. All right.